Today we're going to do example 4 from our booklet. It's on page 6, and this is a really hard example for simplifying with indices. When we look at this, I think the best thing you can do is look to see if you have a common factor. So we need to cancel something out. So if we have a common factor, we will be able to cancel something. So I'm going to separate these x to the power of n plus 2 into x to the n times n squared, because when we multiply indices, we add them. So let's write that again. I'll write x to the n minus 2 as well. That's x to the n times x to the minus 2. And then I've got x to the n minus 4, which is x to the n times x to the minus 4. And then, well, x to the n will just leave as x to the n. I'm just going to write it there so we've got a complete set. So these are all our values. Now I'm going to put them back into the fraction. So I might just do it over here. So x to the n times x to the 2 plus x to the n times x to the negative 2 over x to the n times x to the negative 4 plus x to the n. Okay, so now I'm going to make a comparison with this because I see that I have an x to the n in all my terms. So this is like if I had ax plus ab over az plus a. So you can see clearly that in the numerator and the denominator, you can take out a common factor of a on both of those. So I'm going to do that, but my common factor is not a, it's x to the n. So let's see, I'm left with x to the 2. Now remember, when we multiply indices, we add them. So in other words, if I multiply x to the n times x squared, I'm going to get x to the n plus 2. Don't be confused with the brackets. Brackets, we multiply indices when we have brackets like this, and we multiply the indices. So notice how these are indices. What we've got here, we've got the whole thing, x to the n times x to the 2. So don't be confused with that. We're going to add those when they are multiplied. So plus x to the negative 2. Now, I'm going to go in the denominator and shall unhighlight that. In the denominator, I'm going to take out x to the n as well, and I'm left with x to the power of negative 4 plus 1. So be careful there. X to the n, if I take it out, you have to have something there, and that's the 1. Because if I then try and go back to the expanded form, x to the n times x to the minus 4 gives me x to the n minus 4, this term, but then how am I going to get the x to the n at the end? Well, that's where I need to have plus 1. So I'm timesing it by 1 there. Now, I'm going to see that I've got this common factor. Oops, don't want to rub that out. I've got this common factor of x to the n, and I'm actually going to cancel this out. Let's use blue. Cancel those, and I'm left with x squared plus x to the power of negative 2 over x to the negative 4 plus 1. And these are not like terms, so people get confused. A lot of people who've tried this one say that this is x to the power of 0. No, it's not, because we're not multiplying those indices, we're adding them. So we can't do that. I'm going to make this negative indice positive, and I'm going to do the same on the denominator, but I'll start with the numerator. So x squared plus x to the negative 2, let's put them both over 1, so we've got a vinculum to work with. The x squared can stay where it is. It is a positive indice, so we'll leave that in the top. I'm going to move this x to the power of negative 2 into the numerator, and that gives me, well, x squared over 1 plus 1 over x squared. Now, I can't add these together at this point because we don't have a common denominator. So, well, we're going to make a common denominator. take it up here, and we can see that the denominator that is, we can use would be x squared. So I'm going to put the x squared there, and I can leave that 1 at the top. But if I want an x squared here, remember what you do to the bottom, you do to the top, our golden rule of fractions. So we get x to the power of 4 because multiplying x squared times x squared means x to the power of 2 plus 2. Okay, so now that means in the numerator, I'm going to write numerator there so it's clear where it is. I've got x to the power of 4 plus 1 over x squared. So that's my first bit, and I'm just going to highlight that so we can see where that's going to go. That's the numerator. It will eventually go up there. It's just a different form of x squared plus x to the power of negative 2. Let's do the same thing with the denominator. And of course, the denominator is x to the power of negative 4 plus 1. And once again, I'm going to put a denominator on both of those so that I can pop this negative indice over the vinculum. And it leaves me with 1 over x to the power of 4. Now this 1 over 1 doesn't help too much because I'm going to need a common denominator as we did for the numerator. If I've got x to the power of 4 in the denominator, I'm timesing the power of x to the power of 4 on the top and the bottom. What you do to the bottom, you do to the top. And now my denominator can be written as 1 plus x to the power of 4 over x to the power of 4. So we've now got the numerator and the denominator. So let's see what we can do with that. Probably shouldn't have written in blue, but hopefully you can still see that. So this is our denominator here. Let's keep in mind that, of course, the vinculum, this fraction line, means divide. So if I write the numerator and the denominator as they are, it's going to be x to the power of 4 plus 1 over x squared over 1 plus x to the power of 4 over x to the power of 4. That looks ridiculous and it's pretty hard to work with. So I'm not going to do that. I'm going to keep in mind that the vinculum means divide. So this one here, they all mean divide, but I can separate my numerator and denominator nicely like that. So in the numerator, x to the power of 4 plus 1 over x squared, I've got a division here, divided by 1 plus x to the power of 4 over x to the power of 4. We have a division of fractions, and as we really want to know by now, division of fractions is keep, change, flip. So let's do that. Keep, change, and flip. Okay, now this is the part where it's quite nice. We are going to just cancel out our common factors, remembering that we use the butterfly. So we can find common factors on any of these lines here. Over here, we've got x squared, and here we've got x to the power of 4. So actually, I can divide by x squared. And that will give me x to the power of 4 plus 1, over 1, so x squared divided by x squared is 1, times x to the power of 4 divided by x squared, subtract indices for division, 4 minus 2 is 2, so x squared over 1 plus x to the power of 4. Now, what we see is that those two here were along that line of the butterfly, so I might just point that out so it's clear. And what I mean with the butterfly, when we multiply fractions in this case, we can only cancel down or find common factors if it is along one of those lines. The next place that we can cancel, which isn't quite as obvious, is, let's see, here we've got x to the power of 4 plus 1 and 1 plus x to the power of 4. Now think about it like this. If we have 3 plus 1, that equals 4. If we have 1 plus 3, it also equals 4. So when we are doing this addition here, 1 plus x to the power of 4 is actually the same as x to the power of 4 plus 1. So I'm going to just change that so that it looks a bit nicer but if you can see it's the same, you don't really need to change it. So these two are along this part of the butterfly on that diagonal. And that means that I can actually divide this by x to the power of 4 plus 1 and divide this by x to the power of 4 plus 1. And it means I get 1. So this is 1 over 1 times x squared over 1. Now we can just multiply across, and you may not even need to. It's pretty straightforward here. You can probably see that you're just going to have x squared. 1 times x squared is x squared. 1 times 1 is 1. But of course, we don't need that 1 in the denominator. We don't need to hold that place. So our answer is x squared. That's a really hard example. And if you've been able to follow that far, you've done really well.